Hello everyone, welcome back to the channel. I hope you are doing great and consistent in your DSA journey. In the today's video, we are going to solve one of the most important and frequently asked problem that is based on sliding window problem. So an array is given to us of positive integer and an integer k. You have to find the maximum value for the each continuous subarray of size k. And we have to return the maximum array maximum value corresponding to each continuous subarray. Here an example array is given to us with the value 1, 2, 3, 1, 4, 5, 2, 3, 6, and k value is 3. So we have to find the maximum inside the first three value, that is 1, 2, 3. So the maximum here is 3. So we have to insert this in the output. Again check for the next three value, that is 2, 3, 1, and check for the what is the maximum value in this 231. The maximum value is again 3. Again traverse the same array and go for the next value, that is 314, and again check and find the maximum value. Again do with the next 145, the maximum is 5. 452, the maximum is 5, and we have to store all these value inside the output and we have to return this as an output. Here the next example is also given to us with the value 51341 and subarray of size k. So value itself is the size of the subarray. So we have to simply return this 4 as an output. So for 5, the maximum value is 5. For 1, the maximum value is 1. For 3, the maximum value is 3. And for 4, the maximum value is 4. So each element in an array is its own subarray. So the output is simply the same array. Let's jump into the notebook and see how to approach this problem to solve in brute force way, the better way, and the optimal way. We have seen the problem statement as well as example. Now try to understand this problem using this visualizer. Here an array is given to us and the number of element here is 9. So n equal to 9 and the value of k is also given there and the value here is 3. So it pick the first three value and find the maximum value and put it inside output array. So for first three value here the maximum value is 3. Again check for the next three value, that is 2, 3, 1. Here again the maximum value is 3. So update the output array with the 3. Again check for the next three value and here the maximum value is 4. So 4 is inserted into the output array. Again check for the next three value and here the maximum is 5. Again go for the next. Again maximum is 5. So 5 is inserted in the output array. Again check for the next three value and again the output here is 5. Now this is the last step in which the maximum value is 6 and I cannot proceed with the next three element because this is the last three element. So from here we got an intuition that our for loop is starting from index 0 and the last index value is 6. So how we find this 6 value? So we know that the number of element here is 9 and the value of k is equal to 3. So if we subtract 9 minus 3, we got this 6. So our first for loop is running from index 0 till n minus k. So we are going to solve this problem using brute force. Let's implement this. Now I'm going to write the pseudocode for this, and for storing the maximum value of the subarray, we have to declare one answer variable and then we have to traverse one for loop from index equal to 0 till index n minus k. That is here the 6 value because after this we are unable to find such three pair. So our first for loop is starting from index 0 and it is run till n minus k. And now we have to declare one variable maxi because in every slide we have to find the maximum value and declare it with int min. After this, we have to find the current window maximum. So let's suppose our current window is 0, 1, and 2. So we have to traverse this 0, 1, and 2 and find the maximum and put it inside the answer. Let's suppose this is our current window. So traverse this current window and find the maximum value, that is 5, and put it inside the answer. So from here we got that if I equal to 0, then our j is also starting from index 0 and it is running till the next three value, that is index 2. So j is starting from index 0 and it is running till index 2. So we know that in our second for loop, our j is starting from index I, and it is gonna take the next three value, that is 0, 1 and 2. For finding the j last value, we can say that if we add I plus k minus 1, this also equal to 2, because here index value equal to 0 and k value is equal to 3 and minus 1, we got the value 2. So our j is starting from index I and it is running till value I plus k minus 1. We can take another scenario. Let's suppose I equal to 6. So our j is starting from index 6 and it is run till index 8. So our j is starting from index I and it is running till index 8. For finding this 8, we can say I plus k minus 1. So here I equal to 6 plus k equal to 3 minus 1. So again we got the value 8. After this for loop, for every current window, we have to compare the array j value with the maxi value and update the maxi value, because we have to find the maximum inside the current window. So update the maxi value, and for every current window, we have to push the maxi value inside the answer. So answer dot push maxi. And after pushing all the maxi, we have to simply return answer. Let's try run of our code. In starting, the answer variable is empty, and our I is starting from index 0, and the value inside the maxi is int min, and our j is starting from I, so j is also equal to 0, and it is running till I plus k minus 1. So I plus k minus 1 value is equal to 2. So our first current window value is between index 0 to 2, and we have to find the maximum value inside this current window. So in the current window from index 0, 1 and 2, the maximum value is 3. So we have to push that maxi inside the answer vector. So we have to push 3 inside the answer vector, and after that our I become 1. Now again maxi is equal to int min. Now our j is starting from index equal to I, and it is running till I plus k minus 1, that is 1 plus 3 minus 1, that is 3. So current window index is from 1 to 3. So in 1 to 3 we have to find the maximum value. So in this 1 to 3 the maximum value is 3. So we have to simply insert this 3 inside the answer here, because here mentioned that if you find the maxi value, we have to push that maxi inside the answer array. And after this our I become 2. Again maxi equal to int min, and our j is starting from index I, that is equal to 2, and it is running till 2 plus 3 minus 1, that is 4. So the current window is from index 2 to 4, and in 2 to 4 we have to find the maximum. So in 2, 3, 4 index, the maximum value at index 4, so we have to push that maximum value inside the answer. And after our I become 3, and again our maxi become int min, and our j is starting from I, that is equal to 3, and it is running till 3 plus 3 minus 1, that is 5. And for the current window, the indexes move from 3 to 5, and we have to check that which value is the maximum inside this current window from 3 to 5. So here the maximum value is 5, so we have to push that 5 inside the answer array. And after that our I become 4. Now again our maxi become int min, and our j is starting from index I, that is equal to 4, and we have to run this j from I plus k minus 1, that is 4 plus 3 minus 1, that is 7 minus 1, that is 6. So our current window is from 4 to 6. So we have to find the maximum value inside this index 4 to 6. So from 4 to 6, the maximum value at index 5. So we have to insert that 5 inside the answer array. After that, our I become 5, and again our maxi become int min, and our j is starting from I, that is equal to j equal to 5, and it is running till 5 plus 3 minus 1, that is 7. So our current window is from 5 to 7, and in 5 to 7 indexes we have to find the maximum value. So here the maximum value is 5 again. So we have to again post the 5 inside the answer array, and after update the I, and I becomes 6, and again our maxi become int min, and our j is starting from index 6, and it is running till index 8, and this is the last iteration. So our current window is from 6 to 8, and the maximum value inside the 6 to 8 is 6. So we have to push that 6 inside the answer array. And after that, if we increase I equal to 7, then our this condition become false, because 7 n minus k is equal to 9 minus 3 is equal to 6. So our outer for loop is running till index 6. So we are unable to iterate for index 7. So our execution stops, and after that we have to return this answer. So this is our answer we have to return. Now I'm going to implement this on the code editor. This is the implementation of code, and here we are using two for loops. So the time complexity to solve this problem is big O of n square. Now we are moving forward to solve this problem in an optimal approach. Let's get back to the notebook. In the optimal approach, we are going to use this double-ended queue to solve this problem, because from the both end you can push or pop the value. And in this problem, we are going to store the index of the current subarray inside this DQ in such a way that the index on the front head side represent the maximum value. So whenever we pop out this index, then we are able to find the maximum value of that subarray, and the value of this DQ must be lesser or equal to 3, because the sub array size here is 3, so it cannot be more than 3. If it is greater than 3, then we have to remove from front and push from back. So here the three important point mentioned here, that monotonic decreasing DQ. So I have mentioned here that the largest element index is on the front. So that's why this DQ is monotonic decreasing, and front represent the maximum and the DQ size not greater than key. So this is the approach. Now I am trying to dry run off the code so that it will helpful to you to understand this problem. I have separated this problem into two sections. The first section handle the first three elements, because without finding the first three elements, we are unable to find the maximum in the subarray of size k equal to 3. That's why our first for loop is starting from index equal to 0 till k minus 1. Here it follow the zero base indexing. That's why 3 is not included in the first section. And in the second section, it moved from index 3 to n minus 1, that is 8. So this is the approach. Now I'm trying to dry run of this code so that you can understand the problem. This is the DQ that is going to store the value of the current subarray index in such a manner that it follow the monotonic decreasing DQ. Now this DQ is empty, and there is one more variable, that is answer. So we have to declare one answer that is going to store the maximum value of the current subarray, and we have to return the answer. So right now it is empty. So the first for loop is starting from index equal to 0. So our first index is 0. So store that index inside this DQ, and its value is 1. Now check for the next value of I, that is 1. Now check the value of 1, that is 3, and 3 is greater than 1. So I have already told you that this DQ is monotonic decreasing DQ. So on the front head side, it must be greater index value. So we have to neglect this value because it is not maximum. So it not be the maximum in the current subarray. That's why we are going to neglect this. Now moving forward, Now check for the next value, that is 2, and 2 value is minus 1. So it is lesser than the front value. So no need to delete this front value. Now continue forward. We have successfully traversed this array from index 0 to 2, that is mentioned in the step 1, that we have to traverse from index 0 to k minus 1, and k minus 1 value is 2. So we found the first subarray from index 0 to 2. Now our second task is to find the maximum value inside this first subarray. And we have already maintained the monotonic DQ. So on the front head side, it represents the index of the maximum value on the current subarray. So here index is 1. At index 1, the value is 3. That is also here 3. So we have to store this 3 inside the answer value. So this is the first subarray maximum. Now moving forward, our I become 2 to 3. Now the value at 3 is minus 3. So it is lesser than the previous value, that is on the second position, that is minus 1. So no need to delete this one, this value. After inserting the index 3, we can see that we are found the another subarray. Previously the subarray from index 0 to 2, this is the first subarray, and this is the second subarray. So now again, after inserting this, we have to find the maximum of the current subarray, that is always on the front head. And here again, it is showing that the index 1 value is the maximum of the current subarray. And we have to push this 3 inside the answer array. After inserting this 3 inside the answer, now update the index from 3 to 4. Now, when we insert 4, the size of the array become 4, and here is the limitation that the size of this TQ must be less than or equal to 3. So we have to neglect the irrelevant index that is not the part of current subarray. So we can say that the index second, third, and fourth are the part of the current subarray, and index 1 is irrelevant to the current subarray. So we have to neglect this, and after that we can proceed further. So our first concern is that we have to remove this irrelevant subarray index that is not the part of current subarray. So first we have to neglect this, and now check that at index 4 value is minus 5. So it is lesser than the minus 3 value. It is lesser than the minus 3 value. So no need to delete the index 3 or 2. Now moving forward, the size here is 3, and from the front index, it gives the maximum value. So here the front value is 2, and its value is minus 1. So we have to store minus 1 inside the answer array, and after that we can proceed further, and our index become 5. So whenever our index become 5, again the size of this array become 4. Again the size here is 4. So we have to neglect the irrelevant index that is not the part of current subarray. So again we have to remove this index. So neglect this index, and after that check for the value at index 5, that is 3. So 3 is greater than minus 5, so we have to neglect this index. And 3 is also greater than minus 3. So we have to neglect this one also. So now only one index is present inside this DQ, and the value at that position is 3. So from front, we have to store the value inside the answer array. So now we have to insert the value at index 5, that is 3, inside the answer array. Now moving forward, our index becomes 6, and no need to check the limitation of the DQ because here only 2 element is there. So it is not greater than 3. Now we have to check the value at index 6, that is 7. Here we can say that the 7 value is greater than 3. So we have to neglect this fifth index also. So we have to delete this fifth index, and after that the front value here is on the sixth index. So now we have to again store the value here in the answer array, and the value becomes 7. After moving forward, our index becomes 7, and at index 7 the value here is 1. So no need to remove this front value because it is lesser than the front value. Here the front value is 7 and it is 1. So no need to delete this. And after moving forward, we have to return the front value. And here the front value again is 7. After this, we have to insert the eighth element. And the eighth element value is 6. And we have to compare this eighth index value with the seventh index value. And seventh index value is lesser than the eighth. So we have to neglect this one. And after that, our for loop is successfully terminated because it is run till n minus 1. This is the last subarray and our for loop is terminated. So we have to explicitly return the maximum value that is present on the front index, that is on the 6. So for this, we have to also push the value at index 6, that is 7, inside the answer. So now our answer become 3, 3 minus 1, 3, 7, 7. So this is the answer. Now I'm going to write the pseudocode that will help you in understand the try run. Here the same code is written here in the pseudocode, and our first for loop is starting from index 0 to k minus 1, and our first while condition is that our DQ size is greater than 0. So currently there is no element inside the DQ, so this while loop will not traverse, and simply we have to push the index value inside the DQ. So our first index value is 0. So we have to simply insert this 0 inside this DQ, and the value here is 1. Now check for the while condition, and here we can see for the next iteration, whenever the value is 1, the DQ size here is greater than 0 because there is one element present inside this DQ. So this condition is true, and DQ dot back, that is this value. At index 0, the value is 1. So one value, if 1 is lesser than the value at index 1, that is 3, then we have to pop back this value. So that's why we pop this value and insert the next index value, and its value is 3. So this is the approach for the first 3 index, and after that we have to traverse this index from k to n minus 1, and we have to, after traversing the first 3 value, we have to insert the front value. So here it is written that answer dot pushback nums of dq dot front. So this is the front value. We have to insert this 3 inside the answer array, and after that, after this, there is one more condition. Every time we have to check that the number of element inside this DQ is less than or equal to 3 or not. If it is greater than 3, then we have to pop out from the front. So this same thing is written here that while DQ is greater than 0 and DQ dot front is less than I minus K. Why this I minus K? Because let's suppose our index value is 5. So I here is 5 and k value is 3. So I minus k is 5 minus 3 equal to 2. So only index 3, 4 and 5 value is present inside the current window. So we have to neglect the index 2. So that's why here it is mentioned that the value is lesser than or equal to I minus k. And if it is lesser than I minus k, if the value is 2 or 1, then we have to simply pop from the front because it is not in the current subarray. And then after again check for the rarest value that it is greater or lesser than the current index or not. So if this is lesser than the current index, then again we have to do the same things that is written here. This is the same thing written here. So we have to simply pop from the back, and after that we have to push the current element inside the TQ. And this is the last step where we see that our for loop is terminated and there is the only one element in the last current window is remaining. So for that, here it is written that we have to push the DQ dot front inside the answer. And after that, we have to return this answer. Let me show you the implementation of this code on the visualizer. That will definitely help you. Have a look to this visualizer. That will definitely help you in understanding the workflow of the code. Currently, the DQ is empty and answer vector is also empty. Now at the first step, index 0 is come inside the DQ and its value is 1. And at the second index, the value is 2. So it will definitely remove the index 0 value. So on second step, it removes the index 0 value and now the current index value is 1 that is present inside the DQ and its value is 2. Now at the third step, the second index is come here and its value is 3. So it also delete the previous value. Now we find the first side subarray and its maximum value that is present on the front hand side, that is on the index 2 and its value is 3. So 3 is stored inside the answer. Now moving forward, the next value at index 3 is 1. So that's why here index 3 is added because its value is less than the value at index 3. Now we have to push the value from the front inside the answer array. So value at index 2 is 3. So 3 is inserted in the answer. Now move forward. Now our index become 4 and it replaces the previous index value because previous index value is 3 and 1 and both are less than the index value at 4, that is 4. So that's why the index 4 is updated here in this DQ. And now we have to push the front this front value inside the DQ and its value is 4. So 4 is inserted in the answer. Now moving forward, now at index 5, the value is 5. That's why the index 4 value, that is 4, is replaced with the 5. And now 5 is inserted into the answer. So 5 is here. Now moving forward, again, value at index 6 is 2. So that's why it not remove the index value 5. And now again, the 5 value at index 5, the front value is 5. So 5 is inserted in the answer. Move forward. Similar thing is happened in this code. You can look at this and this will definitely help you in understanding the code. This is the implementation of code. Here the two variable is declared. One is DQ and another one is vector answer in which we are going to store the output of this problem. And our first for loop is starting from index equal to 0 and it is run till k minus 1 and check the size is greater than 0 or not. If it is greater than 0 and array and DQ back element is less than the current value, then we have to pop that value. Otherwise, we have to push the index inside the DQ. And now we have to process the rest of the array from index equal to k to n minus 1. And first concern is that we have to push the DQ front value inside the answer. And after that, we have to check that the current window size is less than 3 or not. If it is greater than 3, then we have to remove from the front. And after that, we have to again check that the DQ.back value is lesser than the current index value or not. If it is lesser than the current value, then we have to again pop back and then we have to push the current index. And for the last index value, we have to push the DQ.front inside the answer. And now we have to return the answer. For the first for loop, the time complexity here is 0 to k. So the time complexity here is big O of k. And in the second, the time complexity is n minus k. So the whole time complexity for this problem is big O of n. So this is the optimal approach to solve this problem. Please try run this code from your end. Otherwise, it will very difficult to understand the code. This is all about the today lecture. In the coming lecture, we are going to solve more complex problem.